Section 7.6, the last section in the chapter. You are solving exponential and logarithmic functions. Now, logarithmic and exponential functions are inverses of each other, believe it or not. So, to solve a log function, you're going to raise both sides to a base. And you're going to do the opposite for exponential functions. If it's an exponential function, you're going to take the log of both sides since they're inverses. It works out very nicely. You are just going to simply love this. Here we go. First example. We're going to solve just by equating the exponents. Now that just means that you're trying to get your bases to be the same. So here our bases are 4 and 8. Think about what number could we make these that would be the same. Well, let's try a 2, because 2 goes into both 4 and 8. We can rewrite 4 as 2 squared, because 2 squared is 4. And then you have 2 squared to the 3x. Equals, now think about how can you rewrite 8 with a base of 2? Well, 2 squared is 4, 2 to the third is 8. So you can rewrite 8 as 2 to the third, then to the x plus 1 power. Now you have a power to a power here, so this becomes 2 to the 6x equals, you're going to distribute this 3 through the x plus 1, because it's 3 times x plus 1. So you'll have 2 to the 3x plus 3. Now the rule is that if you have the same base on both sides, you can just get rid of them. That's right, you can just drop them. So you have now just your exponents left, so 6x equals 3x plus 3. So if you have the same base, you just get rid of them and the exponents come down. Now all you have to do is solve for x. So subtract 3 to this side. So you have 3x equals 3. And then last step, divide by 3, and x equals 1. Pretty simple. Let's do another example. Here now you're going to start working with logs. Now I said up above that logs and exponential functions are inverses of each other. So if you have 2 to the x equals 7, in order to solve for x, to get rid of the exponent, if log is the inverse, you're going to take the log of both sides. And since we have a base of 2, the inverse of that is going to be log base 2. So when you take the log of both sides, you're going to use the base of 2. So you're going to have log base 2 of 2 to the x equals log base 2 of 7. Now since logs and exponents are the opposite of each other, this log base 2 and 2 go away because they're inverses, it's just 1, and your exponent comes down. So you have x equals now log base 2 of 7. Now in order to solve for log base 2 of 7, you need to use your change of base formula in order to solve for this. So x equals log of 7 over log of 2. And if you type that in your calculator, 2.807. So this would be your answer. Now in all of these, when you're rounding, if the directions don't tell you, if you round to 3 places, that should be enough. So if you could round to 3 places, that would be fantastic. Alright, we're going to do a second one just for good measure. You have 4 to the x equals 15. The inverse of exponent is log, so you're going to take now log base 4 of both sides because your base is 4. So your log 4 and base 4 cancel out, and you have x equals log base 4 of 15. So to solve for this, use your change of base formula. I'm going to go over here, so x equals log of 15 over log of 4. And when you type that in your calculator, you should get about 1.953. Let's do one now that's a little bit more complicated. The first thing you want to do is get the exponent all by itself. So here we have 10 to the 2x minus 3, but you have this plus 4 here. Before you take the log of both sides, get this exponent by itself. So subtract the 4 to the other side first. So you have 10 to the 2x minus 3 equals 17. Now take the log of both sides. And now since we have a base of 10, you're taking log base 10 of both sides. I'm just going to write my log on this side so you can kind of see. The log and the 10 are inverses, so the log and the 10 cancel out. You bring your exponent down. And now solve for x. So you're going to do log of 17, and you're going to add 3, because I got to add 3 to both sides. And your final step for solving for x would be divide by 2. So if you type this in your calculator, you actually type log of 17 plus 3 and then divide by 2. Should get around 2.115. Now it's important to use order of operations. Type in your calculator log of 17, then add 3, and then divide by 2. Alright, now let's do something in the other direction. Now you're giving a logarithmic equation, and you're going to solve using its inverse exponents. First off, if you're given an equation that has a log with the same base on both sides, we have log 3 of 5x minus 1, and on the other side we also have log base 3 of something. Just like the exponents did, the bases, when we have the same base, these cancel out. And all you're left with is 5x minus 1 equals x plus 7. And then you just solve for x. So subtract your x and add your 1 to the other side. So you have 4x equals 8. Divide by your 4. You get x equals 2. So it's pretty simple when you have the same log on both sides. So we're going to go ahead and skip that example, because here again, both your logs would cancel out because they have the same base, and you just solve for x. Right, let's talk about when we have to use exponents. So now you're just going to do the opposite. You have log base 5 of 3x plus 1 equals 2. The opposite of log base 5 is the base 5. So you're going to exponentiate, yes, that's a word, exponentiate each side. And you're going to use its inverse. The inverse is 5. So you're going to take each side and put it up in the exponent of the base 5. Make sure you do both sides. So now 5 and log base 5 are inverses. They cancel out. So you're just left with 3x plus 1 equals 5 squared. Well, 5 squared is 25. Subtract your 1. Divide by 3, and x equals 8. So let's do an example where you might get more than one answer, and you have to check for extraneous solutions. In this example, we have log 5x plus log of x minus 1 equals 2. If there's ever a time where you can condense this when you're solving for x, you need to do that first. So in this case, we have log of something plus log of something. Remember that you can rewrite that as log of 5x times x minus 1 equals 2. Because adding is the same as if you take the insides and multiply them. So now that you have just one log, now you can use exponents to cancel some things out. So here we have log, there's no base written, so we just assume it's log base 10 here. So your opposite exponent is going to be 10. So you're going to raise both sides up with the base of 10. Now your log and base 10 cancel because they're inverses. And now continue to solve for x. So if we distribute 5x through, 5x squared minus 5x equals 100. Now here you have a quadratic. So to solve for a quadratic, you need to get everything on one side and set it equal to 0, because you're going to have two answers now that you have a quadratic. And now you're going to need to factor. It might be easier if you pull out a 5 first, because all these have a 5 in common, and then factor. Might make it a little bit simpler. So now you're looking for two factors of 20 that subtract to give you 1. And that's going to be 5 and 4. And this negative means that one is negative, one is positive, one of your signs. And since the middle term is negative, the 5 should go with the minus sign. So your two possible solutions are x equals -4 or x equals 5. So to check which one, or if we have extraneous solutions, you're going to plug these in to the original equation to see if either of them are extraneous. So if I scroll back up, first let's plug in -4. So we have log 5 times -4 plus log of -4 minus 1 equals 2. That gives us log of -20 plus log of -5 equals 2. And when you try and type this in your calculator, you're going to get an error, because you can never take a log of a negative number. So -4 is not a solution. So now we need to check and make sure that 5 is a solution. So we're going to plug in 5. So we have log of 5 times 5 plus log of 5 minus 1 equals 2. Gives us log of 25 plus log of 4 equals 2. And if you type in log of 25 plus log of 4 in your calculator, you get 2. Seriously, it comes up 2. So 2 is a solution. So those are the properties you're going to use when solving for logarithmic and exponential functions. Because logs and exponents are opposites of each other, when you're solving for a log, you're going to exponentiate it. When you're solving for exponents, you're going to log both sides.